All right, good evening. We're going back to trigonometry. So here we have functions in polar coordinates, or relations in polar coordinates, and we're going to try to turn them into something that looks like Cartesian. So first thing we're going to do is remember that we have x is equal to r cosine theta. Okay, that means that cosine theta, okay, is going to be x over r. Okay, so go ahead and think about that. Um, so our first problem here, we're gonna, oh, by the way, r is equal to the square root of x squared plus y squared. So we can go ahead and think about that too. All right, so we're gonna say this is x squared plus y squared is equal to, and then we have 4, and then we have cosine. This is going to be x over r. And what I should have done was really waited to transpose my R, and I'll just wait on that one. So I'll just go back one little moment and just rewind this to say R is equal to, just have R is equal to 4 times x over R. Then we could say that we have 4x equals R squared, right? Next thing we're going to do is now we can think about R squared is equal to x squared plus y squared is equal to 4x. Okay. Now we're not quite there yet because I don't know what shape this is yet. It's kind of weird. So we have r squared or x squared minus 4x plus y squared is equal to, it looks like 0. Okay, I just subtract the 4x to both sides. Now we have to do something called complete the square. So we're going to say this is negative 4 divided by 2. That's negative 2. And square it. And that's always going to give me a perfect square. So we're going to add 4 to both sides here. Okay, so here we have x minus 4 or x minus 2 squared. Okay, so x minus 2 squared plus y squared is equal to 4. Now, going back to college algebra, going back to your algebra class, I could swear that this was a circle centered at 2, 0. So we can go ahead and we can look at this 1, 2, 0 with a radius of 2, right? Because remember, it's r squared over here. So we have 1, 2. So we have 2 and 2, and then we'll go up 1, 2, 1, 2. And we can go ahead and say, pretend this is round. Okay. And that would be, pretend that's a circle. Okay, that would be what the graph of this thing would actually look like, and that's how you convert from r is equal to 4 cosine theta. Okay, very similar problem. We have r is equal to negative 2 sine theta. Okay, let's go back up and look at this. So yeah, so the first thing I'm going to do is say, remember that y is equal to r sine theta, so that sine theta would be y over r. Okay, so we're going to go ahead and make that substitution. So I have r is equal to negative 2 times y over r. So we'll go ahead and multiply both sides by r. So we have r squared is equal to negative 2y. Now it's time to go ahead and say this is x squared plus y squared, say equals negative 2y. And the same thing, I'm going to go ahead and push the y over to the other side. So we have x squared plus y squared plus 2y equals 0. And again, we're going to do complete the square. So I have 2. We have to divide everybody by 2. So 2 over 2, that equals 1. And then we're going to take that number and square it. So 1 squared is equal to 1. So I'm going to add 1 to both sides. All right. So here we have x squared plus, this is a perfect square trinomial. Y plus 1 squared is equal to 1. This is a circle, radius 1, that's centered at 0, negative 1. Okay. So we can say 0, negative 1, and we have a radius of 1. So we're going to go up here, go down here, over here 1, over here 1, and hopefully that'll be a little bit smaller for me to go ahead and draw. And again, pretend that's round, but this is what the graph would look like for my function of r is equal to negative 2 sine theta. Okay. Last one here, we have theta is equal to 3 pi over 4. Okay, so here we have theta equals 3 pi over 4. Now, if you remember what the different values are, so we could say that theta was equal to the inverse tangent of y over x. Okay, so could I go ahead and take the tangent of both sides here? So I could say that tangent of theta would be the tangent of 3 pi over 4. We do that. That might work, but we could go ahead and look at it that way. Okay, so let's see here. We could say that. Oh, no, we don't have to do that. No, we're going to go ahead and say that tangent is equal to 3 pi over 4. Okay, so yeah, tangent of theta is equal to 3 pi over 4. That's what we have. Tangent of theta equals 3 pi over 4. That's where we are. Now, I'm going to ask you, it's like, okay, tangent, we want that. Tell you what, let's do this a slightly different way. So I really want to just graph this thing. So we could say, I look at tangent is equal, or I look at 3 pi over 4. That's going to be 1 pi over 4, 2 pi over 4, 3 pi over 4. It's going to be this line right here. Now, remember doing problems like y is equal to 1, and you'd say, okay, it's going to be this piece right here. So when x is equal to 3, y is equal to 1. X is equal to 4, y is equal to 1. In this case, if r is equal to 1, tangent is still, or theta is still 3 pi over 4. We're going to be looking at something like that. R is equal to 2, theta is still equal to 3 pi over 4. R is equal to negative 1, which doesn't really happen, but theta is still equal to 3 pi over 4. Theta is equal to 3 pi over 4. We should end up with this line here, okay? We should end up with this line. So let's see if we can make that happen. So let's go back and think about this. We have theta is equal to 3 pi over 4. I know that, where are we here? Theta is equal to the inverse tangent, okay, of y over x. Theta is equal to the inverse tangent of y over x. Okay, well, let's keep thinking about this. So, okay. So what value, what of my x or my y is like, what can I do with this to make give me an x and a y value here? Okay. So that's what we're thinking about right here. Give me just a moment here to take care of something. And so let's go back to this. We could say, remember that theta is equal to the inverse tangent of y over x. Okay. So since we know that theta is equal to 3 pi over 4, we can say that we have inverse tangent of y over x is equal to 3 pi over 4. So I'm going to take the tangent of both sides to kind of undo this inverse tangent here. So we're going to end up with y over x equals tangent of 3 pi over 4. Well, tangent of 3 pi over 4 is negative 1, right? Because its reference angle is pi over 4. We're in the second quadrant. Tangent of pi over 4 is 1, whereas the second quadrant has to be negative, so we end up with negative 1. So we can go ahead and say this is y equals negative x, and that is exactly the same function that I have sitting over here. So here is my graph of this y over x kind of a value here. Okay, so that's how we're going to go ahead and untangle all three of these trigonometric or these polar equations or polar functions and see what the graph looks like in rectangular. Okay. The graph is going to look the same in polar or rectangular. Sometimes it's just easier to look at it in rectangular because we're used to that. Thank you very much for watching the video, and I will see you in the next one. Take care.